Hello! This video demonstrates operational principles of assembly block of Etherblade.NET version 2 project. Processing of the incoming fragments depicted on the left side is demonstrated in this video. I'll only be giving general comments about functional principles of this model. If you're interested in detailed logic organization, please pay attention to the text provided and behavior of two depicted finite state machines. The first frame to be processed is non-fragmented frame belonging to green VLAN. The input dispatcher role is to route arrived incoming fragment to the corresponding storage buffer. Out of all parameters associated with an arrived fragment, the input dispatcher is only interested in frame's VLAN number. This frame's VLAN number value is latched and it is used to determine the ID of the buffer where the fragment will be routed and stored. The first available empty storage buffer is normally used to buffer a fragment unless there is an incomplete frame belonging to the same VLAN stored in some buffer already. Derived buffer ID value is latched and is used as a path selector for the data input switch. When input dispatcher raises start signal, that signal instructs elected storage buffer to start accepting Ethernet fragment. When fragment buffering process is finished, the completion code is signaled back to the input dispatcher. This completion code is represented by the light color on the storage buffer. In this particular case, the code indicates that complete frame is assembled and ready to be released. The output dispatcher has been instructed to release the stored frame from buffer 0. You can see this buffer 0 ID written in output dispatcher queue called depgrant FIFO. Now, let's have a look at transmission process of the stored frame. The output dispatcher AXI stream switch acts independently from input dispatcher and driven by the presence of valid data in the depgrant FIFO. The frame has been released. Next, we will see how the brown frame fragment is processed by the system. The new fragment arrives. VLAN rec is latched with new VLAN data. Buffer elected and BFR rec is latched with new storage buffer ID. Switch set, start signal raised, and buffering started. The fragment buffering is complete, and the completion code is different to the one we saw for the previous fragment. In the current case, the storage buffer signals that only partially stored fragment has been received. This partially stored fragment shall not be released from the buffer until the whole frame is assembled. In this case, the output dispatcher is not given any instruction. Instead, the special memory containing IDs of all buffers with non-completed frames called VLAN CAM has been updated. Let's leave partially stored brown frame in the buffer and see the system processing another incomplete fragment belonging to blue VLAN. The new fragment arrives. VLAN rec latched. Buffer elected. Switch set. Start signal raised. Buffering started. The completion code for partially stored frame is signaled by the storage buffer, and the ID of buffer 1 waiting for more fragments to come gets stored in VLAN CAM register. In the meantime, another brown fragment depicted with dotted outline is lost in transit, and because of this the partially stored frame in buffer 0 is never going to be completed and must be discarded. This problem will be resolved once the next fragment belonging to brown VLAN will arrive. The input switch will route this fragment to buffer 0 in accordance to the data stored in VLAN CAM register, and that new fragment will displace currently stored data. Let's see how the blue frame is going to be assembled in buffer 1 following arrival of the remaining fragment. The new fragment arrives, VLAN rec latched. The data for blue VLAN is stored in VLAN CAM register, so the destination buffer ID is taken from VLAN CAM. Switch set. Start signal raised. Buffering started. The completion code is signaled by the storage buffer, indicating that the whole frame has been assembled. Data for blue VLAN is cleared from VLAN CAM register, and output dispatcher was instructed to release the frame from the storage buffer. Blue frame is ready for transmission, but we will return to this transmission process later in this video. For now, let's see the processing of the last purple frame. The new fragment arrives, VLAN rec latched, buffer elected, switch set, start signal raised, buffering started. The completion code is signaled by the storage buffer, and the output dispatcher gets instructed to release the frame from the storage buffer. As you can see on this slide, there are no storage buffers that currently can accept new fragments. This is the reason why special black hole buffer 3, preventing input interface blockage, has been implemented. So at last, let me show a few slides demonstrating transmission phase for blue and purple frames. Blue frame transmit started. Blue frame transmit complete. Purple frame transmit started. Purple frame transmit complete. This is the end of this demonstration video. Please refer to other project documentation for more details, and thanks for watching.